solving exponential inequalities. So in this video, we will solve these kinds of inequalities like 2 raised to x is less than or equal to 4 raised to x plus 1. So let's go. Okay, in order for us to solve exponential inequalities, we have to use this exponential inequality property. If b is greater than 1, y equals b raised to x is increasing for all x. Because the graph is like this, of y equals b raised to x for b greater than 1. Meaning, if b raised to x sub 1 is less than b raised to x sub 2, then x sub 1 is less than x sub 2, or the converse of the statement. This implies also this one. So meaning to say, if you're solving an inequality with the same base, you just remove the base and then the exponents will be left. So if it's less than, it's still less than. But if this is greater than, this is still greater than. That is if b is greater than 1. But if b is less than 1 but greater than 0, then because of the decreasing behavior of y equals b raised to x, we will have b raised to x minus 1 greater than b raised to x minus 2 if and only if x sub 1 is less than x sub 2. Okay, because it's decreasing. So greater y value than the other will give you a smaller exponent for that. Okay? So greater y, smaller exponent, smaller x. So please take note of the change in the inequality symbol here. Okay, if it's greater, it becomes less here. If this is less here, it becomes greater here. Okay, let's have an example. Solve 2 raised to x is less than 4 raised to x plus 1. Okay, so we should write these two with the same base. So 4 is a power of 2, so we will write the as power of 2. 4 is 2 squared, so using the property of exponent, we will multiply 2 with x plus 1. We will be having 2 raised to 2x plus 2. And then, using the property of inequality there, exponential functions, or the property of exponential inequality, we will have x should be less than 2x plus 2. And then, what are we going to do? Subtract 2x from both sides of the inequality. We will have negative x is less than 2. And then multiplying negative 1 to both sides of the inequality, we will have x is greater than negative 2. If we multiply a negative number to both sides of the inequality symbol reverses. That's what you call the multiplication property of inequality. We have 2. If we multiply a positive number to both sides, the inequality symbol is retained. But if we multiply a negative number, the inequality symbol will reverse. The less than will become greater than. Okay? So all numbers greater than negative 2 can satisfy this given inequality. Or in interval notation, that is from negative 2 to infinity. Parenthesis on or with negative 2 because negative 2 is not included in the solution. So if you will graph that on the number line, hollow circle for negative 2 and all the numbers on the right can satisfy the given inequality. Example number 2. Solve 9 raised to x minus 2 is less than or equal to 3 raised to x. So 9 is a power of 3. So we will write them as powers of 3. So 9 is 3 squared. So 9 is 3 squared. So multiply 2 to x minus 2. You will have 2x minus 4. Don't forget again to distribute 2. And then using the property, we will have, since the base is greater than 1, we will have 2x minus 4 is less than or equal to x. And then we will have, transfer x to the left, transfer negative 4 to the right, you will have 2x minus x is less than or equal to 4. So that gives us x is less than or equal to 4. So meaning to say, all numbers less than or equal to 4 can satisfy this given inequality. Or in interval notation, that is from negative infinity to positive 4, bracket with positive 4 because 4 is included in the solution set. Okay, so on the number line, if you will draw that 4 with a solid circle and all the numbers to the left of 4. Okay, let us have our third example. Solve 11 raised to x is greater than 121 raised to 2x minus 3. So write this with the same base. 121 is 11 squared. So you will have 11 squared raised to 2x minus 3. Applying the properties of exponent, you will have 11 raised to 4x minus 6 here. So since the base is greater than 1, we will have x is greater than 4x minus 6, and then subtract 4x from both sides of the inequality. We will have negative 3x is greater than negative 6, and then multiplying negative 1/3 to both sides of the inequality, or that is the same as dividing by negative 3, you will get x is less than 2. Take note that the inequality symbol here reverses because we multiplied a negative number. Okay, so that's the multiplication property of inequality. So all the numbers less than 2 can satisfy the given inequality. Or in interval notation, this is how you write it. And then on the number line, we will have this. Okay, so all numbers less than negative 2 will satisfy the given inequality. Number 4, 1/5 raised to 3x minus 1 is less than or equal to 1/25 raised to x plus 1. So we can write this as 1/25 as 1/5 squared. Okay, copy x plus 1. And then applying properties of exponents, we will have 2 times x plus 1, that's 2x plus 2, is less than or equal to, this one is less than or equal to this. And then, if you look at the base, that is 1/5. We also have 1/5 here. And 1/5 is less than 1. So if it's less than 1, and this expression is less than this, meaning to say the exponent, this exponent is greater than this exponent. And we will have 3x minus 1 is greater than or equal to 2x plus 2. That's the second property. And then solve for x. Transfer 2x to the left. Transfer negative 1 to the right. You will have 3 minus 2x greater than or equal to 3. That is, x is greater than or equal to 3. Meaning to say, all numbers from 3 up can satisfy the given inequality. Okay, so on the number line from 3 and all the numbers to the right. Or you can have an alternative solution for this. Instead of using 1/5, you can use 5 instead for the base. Okay, so 1/5 is 5 raised to negative 1, and 1/25 or 1 over 25 is 5 raised to negative 2. Applying the laws of exponents, this is going to be 5 raised to negative 1 times 3x, that's negative 3x, negative 1 times negative 1, that's positive 1. And then here, negative 2 times x, negative 2x, negative 2 times 1, negative 2. Okay, and here, the base is greater than 1. So if the base is greater than 1, and this expression is less than or equal to this, meaning to say, this exponent is also less than this exponent. So you will have negative 3x plus 1 is less than or equal to negative 2x plus 2. And then transferring negative 2x to the left, we will have positive 2x. Transferring 1 to the right, you will have negative 1. So negative 3x plus 2x is negative x. And negative 2 times minus 1 is negative 3. And then, solving for x, multiply both sides by negative 1. So if we multiply by negative 1, we will reverse the inequality symbol. We will have x is greater than or equal to positive 3. Same as this. Okay? So if you use the solution, it's okay. You will get this answer. If you'll have another solution using a different base, you will have the same answer. Okay, let us have our final example before we have our practice exercises. So here in this video, we have 5 examples and also 5 items for practice. So we have 2/3 raised to 4 minus x is greater than 8 over 27. So we have, okay, I just wrote that. And so we have here 2/3 raised to 4 minus x is greater than 2/3 raised to 3. 8 over 27 is 2/3 raised to 3. And then, since 2/3 is less than 1, this expression is greater than this if this exponent is less than 3. Okay, so 4 minus x is less than 3. And then transfer 4 to the other side. It's going to be negative 4. So negative x is less than negative 1. Multiply negative 1 to both sides. You will have x is greater than 1. Okay, multiplying a negative number will give you or will reverse the inequality symbol. So negative 1 times negative 1 is positive 1. So in the number line, we have 1 to infinity, or all numbers greater than 1 will satisfy the given inequality. So hollow circle for 1, and all the numbers to the right are solutions to the given inequality. So that ends our presentation of the lesson for solving exponential inequalities. I hope that you learned, and this video will help you answer the following practice exercises. So good luck!